So let's go ahead and start into section 8.2. So the previous section, we looked at the vertex and the axis of symmetry, what cut a vertex in half, that goes right through the x-coordinate of the vertex. We're going to build on that, and we're going to look at things called transformations, which are basically starting with the standard quadratic, which is just x squared, sort of our model equation. And we're going to transform it. We're going to move it left and right, up and down, and a combination of those. And we're going to see how that affects and changes the equation. Okay, so we saw a little bit of that in the last section. And one of the things we can watch, the reason we get to this with quadratics is because that vertex makes it a unique function to work with. We can see what's happening to a parabola more than we can with just about any other. X cubes, you get a little bit, but not as good. Quadratics are really a lot easier to see. Lines are terrible because they're just straight. There's no way to follow them. But with a quadratic, you see very easily what happened. You just have to follow that vertex and you know what's going on. Okay, so let's go ahead. We're going to do some basic transformations of just ax squared. So we're, simple things. We're kind of like, let's not worry about bx plus c. We'll talk about those later. We're going to do vertical and horizontal translations. That's moving up and down, left and right. And then we're going to look at a little bit of modeling. I don't think we do too much with it, but this is our main thing, is moving quadratic equations, controlling it. And we'll see this one, as we change that value, it can make it a thin or wide. It can do that. That's kind of what its control is. So the graph of ax squared. So if a is larger than 0, it will open upwards. Okay, that's what we know. So we've looked at those cases. And then what happens as a increases, you make it larger. What that means is the y values are getting bigger faster, because whatever x squared is, you multiply it by a bigger number. So it's going to squeeze, it's going to make the graph itself look narrower. Okay. So when a is greater than 0, the graph of y never lies below the x-axis. So notice it's always above the x-axis. Here we are. And you can see as the value in front. So this red one has a value of 1. This green one has a value of 2, and that's sort of narrower. And then with a value of a half, it's wider. So as you get to fractions, that's how you get it wider and wider. So, if you graph y equals 0.25, which would be a quarter, it would be a little bit further out here. So it gives you a rough estimate of how to do it. The same sort of thing happens when a is less than 0, except it's upside down. It's just what we would call a reflection. We'll talk about those later. But yeah, this is just a reflection. So it's opening downwards. But the same thing happens as it's, again, this one, the number in front, since it's negative, is actually getting smaller, because -2 is smaller than -1. But if you would think of it, it's larger in absolute value. So the same thing, same sort of process is just take the negative off. As the number in front becomes larger in absolute value, it becomes narrower. As it becomes a decimal, more of a decimal, it becomes wider. Okay, the negative makes it open downwards. Okay. So it just tells us if this is all there is to it, there's no B or C, because B and C are 0. Let's say that. That's a better way to do it. There is B and C, but they're just both happen to be 0. That it will have as its vertex 0, 0. You saw both of those cases had a 0, 0. It will open upward if A is greater than 0, and open downward if A is less than 0. A is negative, right? If A is equal to 0, we don't have a parabola, okay? That's one case they didn't talk about, but we don't. It's wider at the graph as if the absolute value of a, so notice that's what they're dealing with, absolute value, if it's between 0 and 1, so a decimal, 0.5, 0.24, 0.1, as that decimal gets closer to 0, we get wider and wider, okay? Then as the absolute value gets larger than 1, as it gets larger, it will get narrower actually, right? Narrower, because we're multiplying, the y values are getting bigger faster, however you want to think of it. So those are the properties. So we just look at this one. So we've got two examples. We've got a graph here and one here. Wants us to graph both functions on the same coordinate axis. But before we do that, let's see. Both are going to have a vertex of 0, 0. G of x, which way does it open? Yeah, you got it. Downward because of the negative. F of x, which way does it open? Yeah, you got it. Upward because it's positive. Which one is going to be narrower? Yeah, g of x will be narrower because it's got a coefficient of 4 in front. The coefficient in front of f of x is 1, so it'll be less narrow. So let's see if we could do if I can come up with a general graph here. So negative 4x squared, it's going to open downwards, and it's going to be sort of more narrow. So it's just not real beautiful. So that's our g of x. F of x is going to open upwards, and it's going to be a little bit wider. And to get the exact feel of this, let's do it with decimals. And so that first one was blue. So let's see, click and hold. I'll turn it to color, click and hold. Let's turn this one to blue, and this one is going to be minus 4x squared. See, and it's opening downwards and it's pretty narrow. The next one will be y equals, what was that, just x squared. Okay, it's opening upward. Let's go ahead and change it to red because that was the red function. And you see, yes, the x squared is a little bit wider. I probably overemphasized it. Also, we're kind of zoomed out here, so as we zoom in, maybe that's more of a standard look. You can see, yes, this one is wider than that one. Okay, so that's a good look. We could sketch it now if we needed to. Okay, but they're going to go ahead and do it for us. So there we are. That's all we needed to do. Look at the two graphs. Okay, and you guys did a good job. Good. So now the other thing is what we want to see is what happens. So we could graph these also separately. We could do, so we're kind of done with that part of it, the ax squared. Now we're going to start looking at horizontal translations. Horizontal and vertical. I forgot to read the line there. This first series, obviously, we're going to see is vertical. They're going up and down. So if we take x squared, we know that that goes through 0, 0. Watch this. When we add 1, what are we doing? We're calculating the y value, and then we're adding 1 to every y value that we calculate. That's going to move it up. That moves the y values up. Okay. If we, in this case, subtract 2, what we're doing is it's after the y value has really been calculated. We plugged in the x, we got a value. Then we subtract 2 from it. We're subtracting 2 from every y value if you consider it in comparison to the x squared, right? So that moves everything down by 2. Every point by point, is moved down by 2. It's a translation downwards. So that's what we call it. So if I put in a fourth one down here, y equals x squared plus 83. What did I just do? I moved it up 83. Good. If I put this one in here, y equals x squared minus 16. What did I just do? I moved it down 16. And what I'm moving is I sort of always think that I start with our comfort function of just y equals x squared. That's our base, and we build everything else from there. So then I start with that 0, 0, and then I can see as I add 83, I move 83 up. If I subtract 16, I move it 16 down. Okay, that's vertical translations. Okay. Now this is a little more difficult to see sometimes because it's not quite as direct. What we're doing with these, and these are, as you can see, are horizontal translations, is we are coming in the x. Before we do a calculation on the x, before we square the x, we're subtracting 1 from it. So what we're effectively doing is like moving that x-axis. You're kind of pulling the rug out from underneath it. And when you do that to somebody, you pull the rug this way, they fall that way. They kind of go opposite. Think about when you look in a mirror, everything is opposite. So when you're working inside a function, the opposite happens. So you see this -1, but the parabola doesn't move in the negative direction. Look at over here, it actually moved in the positive direction because we're pulling the rug out from underneath it. So it forces it, it goes back the other way. It doesn't go the direction we pull, it goes the other way. That's how. Not I'm suggesting that you pull the rug out from somebody, but give it a try with like a maybe a drink that's not full or not glass, plastic. But see, when you pull something out, what happens? It goes the other way. When it tips over. It will come with it a little bit, right? But if it tips over, it goes the other way, especially if you pull fast enough. That's what's going to happen here. That's what I want you to remember, is that we go in the opposite direction. So we will move to the right. I'm just going to emphasize the positive direction. By this many units. So let me just throw this out here. What if I had y equals x plus 5 squared? And notice it's all happening inside the function. The function really is just a squaring function. So we do it before anything happens. What we're doing in this case is we're pulling out the rug, but this time this is going to go in the negative direction. So this will go 5 to the left. And I'll just put negative direction. Right? And we can graph these. We will graph these, right? And I think that's kind of the best way to do it. So we've got a y equals x squared here already. Let's get rid of this guy. Let's go ahead and leave it red. And then what we'll do is we'll make the new ones just like we did, right? So y equals parentheses. Let's go ahead and do that x minus, let's go x minus, I just want to make it a little bit bigger because we're here. Let's go x minus 3. And those are always, and then we're going to square it. So we can kind of see the vertex has moved over here, 0 to 3. So that's what we watch. The vertex, which is 0, 0, is now 3, 0. So move to the right 3. Let's go ahead and put that next one in. So where am I here? Let's go ahead and put in y equals x plus 5 squared. And notice we've got it over here. It got moved. It's at -5. So this is basically just picking up this red one, sliding it over. That's what it's called, a translation. So it got moved over -5. There's a +5 here, so it got moved to -5. There's a -3 here, so it got moved to +3. Just remember the inside. When we deal inside the function, everything's going to be backwards. And when you get to college algebra, you'll be doing some more types of transformations. They call them not just transformations. You do transformations. These are translations, all right, which are a specific type of transformation. But we're also going to squeeze them, stretch them, rotate them, reflect them. We're going to do a lot of things in college algebra that we're not going to do here, but this is the basis of it. What you're getting here is anything inside does opposite. Remember when we did it outside the function, if we added 5, it went up 5. That's what we would think happened, right? Plus 5, go up 5. If you subtract 10, it went down 10. That's what we would think happened. You subtract 10, it should go down 10. And when you look at this, you say, well, I'm adding 5 to x, so shouldn't it go 5 this way? Not so fast. Remember, there are physical actions where every action has a equal and opposite reaction. So you pull the rug out, person falls the other way. That's what's happening to this parabola. Okay. Good. And we just got a little bit more to go on here, I think. Yeah, we're just going to look at a couple more cases. So if we add 2, notice they show that it moved 2 to the left. And what they did is they calculated each of the values. And what you see is, see this 412? What they're showing, I guess I should back that up too, but what they're showing is, look at the x-axis. If you think of it, the y's didn't change, it was the x. So instead of being -2, we moved the x-axis is now negative. So the value that was at -2 is at -4. And look at the value that's at 0, that was at 0 is now at -2. So it's like we're moving the x-axis. And I guess it's staying in place or whatever, but we're just pulling the rug out. Okay, so that's how it works. And this is what we're going to get. So we've got, when we add to the outside, we're changing the y value. So addition goes upward, subtraction goes downward on the outside of a function. When we're on the inside of the function, we're affecting the x. So that's going to be left and right. And again, a negative goes in the opposite direction, goes in the right direction, which is positive direction. And a positive will move it to the left, which is the negative direction. And it's just nice how when you're inside the function dealing with everything, it's always backwards. You know, what your gut tells you, I think it's going to get bigger. Well, if you're inside, it's actually going to get smaller. All of these type of things. And this is just a perfect example. This is outside the function. So this part here, this part here is inside the function. And what do I mean by inside? Well, it's inside the parentheses. It happens before you square. So the inside stuff always happens backwards. The outside stuff is exactly what you see because it's transparent. What you see is what you get. Inside, there's some tricky stuff going on. Okay, so now we want to sketch this graph and identify the vertex. Well, just think of it. It's x squared, right? Looks like this. Since it's -3, it means it's going to move it 3 units here. So 1, 2, 3. It's going to be over here. So the vertex is now going to be at 3, 0 instead of 0, 0. Again, you could do that with the graphing calculator too. It's been, oh, wait. I was stuck inside. Sorry, folks. I was trying to be too smooth, right? And you probably were catching it, which is actually a good thing. X squared -3. The 3's on the outside. And so that's why I always use these guys. They get me. So we've got this. We move it down 3 because it's affecting the y values. So we're now at 0, -3. It looks something like this. Okay. So yeah, okay, that's all you have to do. Take the graph that was up here, move it down. The vertex is going to be 0, -3. Now we can do the inside stuff, right? We're inside the function. This is going to go left or right. Well, positive usually goes to the right. So it does the opposite. It's going to come here to the left. So it's going to be a vertex out here. Notice it's all positive. So it's going to be at -4, 0. It's been translated left 4 units, went to the left, went in the negative direction. And so that's exactly what they're going to show. Okay. Oh no, we've got confusion here. No, we don't. We just have a vertical change and a horizontal change. So we keep track of it. Remember, vertexes always start at 0, 0. Again, we got this, so we're thinking we start here. And all we have to do is, so there's no negative here. I guess it doesn't really matter, but we'll follow order of operations. Let's move it, let's see, a negative, so we're going to go to the positive direction 1. And then this, and the negative 2 is going to move it down 2. So there's our new vertex. It still opens upward, so it looks like the standard one, but it's just there. That's where our new vertex is. It's at the point positive 1, negative 2. 1, negative 2. Okay, see how you can just kind of pick it out? Change the sign here, but keep the sign here the same. Down 2 units, right 1 unit. There it is. There it is. We can figure this out. So always the opposite on the inside part. Outside part is just how you see it. And that takes us to the end of this unit. So we're getting a nice overview, a nice, let me bring back there we go, my city view, top of the world, right? That's where we're at right now. So what I want you to do is with these units, these are really your gateway concepts into college algebra. Take a look at them, understand the basis that we're doing things on the simple task. When you get to college algebra, you'll be doing similar things, but you're going to add some more things to it. And if you come in with this understanding what we're doing here in this simple moving it left, right, up, down, that same conceptualization will work for all the myriad things we start doing to quadratics, and then in college algebra, you even do it to things that aren't quadratic. So now you got to be able to keep track of other sort of functions, but you're going to be fine because you've got this basis. You've got it, sort of this gut feeling about it. You've got this heart feeling, not just a mental thing that you might remember or might not. You're kind of getting some conceptions and you're getting some things that are going to stick. So keep making your good progress, keep doing the homework, keep letting me know if you have questions. Contact me through email, send me copies, screenshots of things you have questions on. I will get them answered, okay? And we always have the class meeting times that we can meet up at as well. Thank you, be well, keep safe, and we will make it through.